So type 2 is solving by factoring out a GCF. So in example 3 here, first thing I notice is that my range is given in degrees, so that means my answer will be in degrees. I'm going to go ahead, and so we're in quadratic form, and when we factor out a greatest common factor, we're going to end up setting each of those factors equal to 0. So I'm going to go ahead and set this equal to 0. So I'm going to go ahead and move over the left side sine theta to the, or I mean the right side to the left side. So first thing I'm going to do is set equal to 0. So if I do that, I'm going to get 2 sine squared theta equals sine theta. I can rewrite that, so I'm going to get 2 sine squared theta minus sine theta equals to 0. Now I'm going to go ahead and factor out a GCF. So I'm going to factor out a sine theta. That's going to leave me with 2 sine theta minus 1 equals 0. So now we have two factors set equal to 0, so we need to split this into two equations. We have one here, one is sine theta equal to 0, and one is 2 sine theta minus 1 equal to 0. So we're going to have two equations. I'm going to set them up over here. So our first equation will be when is sine of theta equal to 0. Our second equation will be when is 2 sine of theta minus 1 equal to 0. So sine equal to 0, we're going to check and see if that's an exact value. If I come up here, I can see sine is equal to 0 at 0 and at pi. So those are one of those axes angles. So we don't have to worry about quadrants and positive and negative. We can just say that our solutions are at 0 and 180 degrees. 0 degrees and 180 degrees. And that comes from those axis angles where our angles open up and end at an axis. So we can kind of, if we want to think about that, that's going to occur when you think of our unit circle. And so these solutions are occurring here at the point 1, 0. This is at 0 degrees. My sine here is 0. And over here at 180 degrees, when I have the point negative 1, 0, my sine is 0. So it occurs twice on one rotation around the unit circle. So we have two solutions so far. Now we need to go over and say 2 sine theta minus 1 equals to 0. We need to solve this equation. I'm going to get sine theta by itself, so I get 1 is sine theta equal to 1/2. So we're going to check and see if this is an exact value. Let me go back over here. This was an exact value. Is sine 1/2 an exact value? And it is. So this is an exact value. So we're going to go to our chart. When is sine equal to 1/2? That's going to be at pi over 6. So my reference angle here is at pi over 6, which is 30 degrees. Now I have to think about which quadrant my solutions are. Since I'm looking for a positive, I need to think, when is sine positive? Sine is positive in quadrant 1 and quadrant 2, so I'm going to have solutions in quadrant 1 and quadrant 2. So sine is positive in quadrant 1 and quadrant 2. So now I can come up with my solutions. My solutions need to be in degrees. My quadrant 1 solution is just going to be 30 degrees. My quadrant 2 solution is going to be 180 minus 30 degrees, or 150 degrees. So I have 1, 2, 3, 4 solutions. Example 4, we're going to do the same thing. I need to notice that my range is given in radians, so my answer will be in radians. I'm going to go ahead and this is already set equal to 0. So I'm going to go ahead and factor out a greatest common factor. So I'm going to factor out a GCF. So if I rewrite this, cosecant x times cotangent x minus 5 cosecant x equals 0. I can factor out a cosecant. I'll factor that out front. And I end up with cotangent x minus 5. So once again, I have two equations that I'm going to set up. One is cosecant equal to 0, and one is cotangent minus 5 equal to 0. So I can set those up down here. We'll start with when is cosecant x equal to 0, and then our other one is when is cotangent x minus 5 equal to 0. So if we look at let's start with cosecant x equal to 0. I'm going to look at my chart. I do not have that cosecant is equal to 0. So let's think about why that is true. If you think about it, cosecant is really the flip of sine. So this is really saying sine of x is equal to 1 over 0. Can we have 0 in the denominator? We can't have 0 in the denominator. This is undefined. So therefore, cosecant of x is not going to exist. So there's no solution here. And if you think about it, sine is really opposite over hypotenuse, and our hypotenuse will never be 0. If we have a right triangle, we can't have a hypotenuse of 0. Our hypotenuse is always the longest side. So therefore, this is an undefined or a no solution. So we can go over and solve for cotangent x minus 5. So I'm going to go ahead and solve this and say, well, when is cotangent of x equal to 5? This is not on our exact value, so we need to use our calculator. And we need to make sure we're in radians, because our answer needs to be in radians. If we're using our calculator, we don't have a cotangent button, so we have to think about this in terms of tangent. So I'm going to think about this as tangent of x is equal to 1 over 5. And to find my reference angle, I'm going to use tangent inverse 1 over 5 is equal to x. So if I plug that into my calculator, I'm going to make sure I'm in radians. Tan 1 divided by 5 gives me 0.197395, so I'll round that to 0.20. So that means my reference angle here is 0.20. So let's kind of put together what we need here. my reference angle is equal to 0.20. I need to think to myself, when is tangent or cotangent positive? So cotangent, tangent, when is that positive? I can look at my chart. Cotangent, tangent is positive in the first quadrant and the third quadrant. So my solutions will lie in the first quadrant and the third quadrant. So I will be in quadrant 1 and quadrant 3. So let's move up here and give our solutions. So my solutions will be a quadrant 1 solution is 0.20. My quadrant 3 solution is going to be pi plus 0.20. And so that will give us, where am I? 3.34. And so that gives us two solutions. So we have a solution here, we have a solution here, and then over here we had a no solution.